Hello, my name is Dave Balkin. I'm a computer science professor at Washington State University. And now I'm going to tell you about our demo with GridStat on DETER. Well, power grids, as we all know, are increasingly stressed, and inadequate communications has led to a number of blackouts, and it's almost always a major contributing factor. Much better communications can help mitigate this and provide greater efficiencies, etc., enabling control loop applications, closed loop distributed control, regional protection, etc. But there are problems in developing such communications infrastructures, be able to mimic a wide area network that they have to run in. Testing anything at scale is very difficult, and testing under cyber attacks in particular. So today's demo is going to be telling you about some technology we're using to help with this. Okay, well, GridStat then, in a nutshell, is next generation power grid data delivery systems for the wide area. It's real-time, mission-critical, publish-subscribe. It's tailored specifically for the needs of the power grid. Very high availability, very low latency. You can rapidly change subscriptions to adapt the data delivery system to different conditions. And I'd point you to the paper here we had in the recent proceedings of the IEEE for more information on that. So, what I'm going to show you now is how GridStat works. Here you have the cloud in the middle, and it has GridStat routers. They're called forwarding engines. They do rate-based forwarding, and the management plane is on top. It exerts control over the cloud. And here we have, off to the left, we have two publishers. A at the top, A is being published at 60 samples per second, and B at 30. On the bottom, we also have two different subscribers. A is subscribed to at 30 Hertz by the top subscriber on the right, and A is subscribed to at the full 60 cycles per second by the lower subscriber, and B is subscribed to at 15 cycles per second. So first, here we show the setup of the path for A to get to the subscriber there at 60 Hertz, and this subscriber asks for two different paths, so GridStat gives it two different paths. You see the second redundant path there. The numbers on the lines are the rate that it's going at, the samples per second. Okay, and B then is subscribed with no redundant links, just one single path there, and notice that it is produced at 30 samples per second, but after it hits the first forwarding engine, it's only going at 15. This is because that's what it's being subscribed at, so GridStat does rate downsampling in order to help with the network traffic, help reduce it where no unnecessary traffic is sent. Here we have then the other subscriber to A is asking for it at 30 Hertz, so also there it did in-network downsampling from 60 to 30 Hertz to get to that. Okay, so DETER then, an overview of DETER, it's a network technology. It supports a number of high-end PCs, very good network connections, and huge amount of flexibility. You can have nodes there being forwarding engines, you can firewalls, you can have traffic generators, attack generators, traffic shapers, and very nice automated test experiment teardown and setup. And the user has very complete control of experiment, which is very helpful, and those experiments tend to be fairly repeatable, which is very hard to accomplish in a normal laboratory test bed for researchers. So DETER then helps GridStat just debugging anything at large scale, be able to evaluate the performance under load, under how it does under IT failures, under cyber attacks, all very important, necessary capabilities that DETER adds. So I'm going to tell you about a demo we have now that we're going to show you. This is the real-world system from Bonneville Power Administration. They were kind enough to let us have their GIS database on this. They have 521 substations and 614 transmission lines. And GridStat is overlaid on top of that to demonstrate the capabilities. The GridStat network has 521 publishers then, one for every substation, 5 forwarding engines there. And you see they're numbered 1 through 5. Off to the left in green is the subscriber. And the map is carved up into regions numbered 1 through 5. And if that forwarding engine goes down, then those subscribers are cut off. Or the publications from there are cut off from the subscriber. So we'll see how that works if there's no redundancy. So a little bit more detail in the architecture of the demo. The region 2 is being published on 2 independent paths. They're in blue there. And region 4 substations are only publishing on one path, the red path there. All the other subscriptions are on one path. So we're going to see that demonstrated here, and this is using technology, I should mention, that has a huge amount of TCIPG labor for a number of years, and then we had a summer student at ISI that ported to DETER. So here we see the 5 regions there. The substations are all in blue. Everything is fine. Blue means that they can get through their sensor publications are getting to the subscriber. Now we're going to take down line 1, 2 on the top there. And because of that, region 4's only connectivity, it gets routed through line 1, 2. So as a result, the substations here, their sensor publications can get to the subscriber. That's why they're in red. Okay, but region 2s are still getting through because they had an extra redundant path. Go ahead and let's take down line 2, 3. DETER will do that for us here. And now this region goes red because the second redundant path was lost. Okay, now we'll have DETER restore line 1, 2. And you will see the substations in both regions come back now. I should mention that GridStat is not nearly this slow. It's the polling interval with a KML server and everything. And also, this and much, much, much more can be automated for all sorts of experiments and attacks. But this hopefully gives you a little bit of the flavor of how this works. Okay, and towards GridSim and DETER, last year at this industry day, we demonstrated GridSim. It has a commercial simulator that's streaming power data, and we've got it running recently in faster than real time on the 6,000 bus case from the 1996 Western blackout, and at 5 hertz, and it pumps out PMU data. It's delivered through GridStat, and then we have a linear hierarchical state estimation and oscillation monitoring applications, and there's a lot of contributions between GridStat and DETER that are possible, and we're hopeful in the future to work on that. GridStat and DETER, taking a step back, provide basic cyber-physical power test bed for engineers. Running in the Illinois DETER cluster here adds some very nice power-specific content. RTDS is very helpful, getting direct data from PMUs, have access to some of the other devices here, relays, etc. And in the future, GridStat on DETER would offer a very nice cyber-physical sandbox, be able to jointly evaluate the anomalies of both the power grid and the communications and their effect on power. And this is something that's vastly understudied, the effect of the communications infrastructure on power stability. Very understudied, but very important. GridSim also helps get around the problem of getting access to real data from utilities who are very hesitant to share. So again, being able to crank out a lot of data and share it with researchers here gets around that some. So that is my presentation for today, and I'll take any questions now.